All right, class. So, finding zeros of cubic four-term polynomials. First things first, let's remind ourselves what a zero is. A zero is an x value when y is equal to 0. So when you make y equal 0, x can only be so many things. Sometimes it can only be one thing. Sometimes there's no x's that make y equal 0 at all. But whatever x values do work, they do make y equal 0, those x values are called zeros. So let's find some zeros for this function. This function is a four-term cubic polynomial, and we want y to equal 0. So I'm going to make y equal 0. Now, the first step in this process, similar to things we've done before in earlier videos, we want to factor this polynomial so that we can solve each factor separately. So let me factor the polynomial. First, I'm going to find the GCFs of the two groups. Let's see, x squared and negative 4, I believe. And then the remaining bits, 2x cubed minus x is 2x minus 3. And 2x minus 3 again. Okay, perfect. So I've got matching factors. Let's see. I'm going to bring the matching factor out to the outside. Okay. And then the leftover bits right here. Now, am I done factoring, or is there still more to do? Well, 2x minus 3, that's already linear. It's first degree. There's not going to be anything I can factor out of that. But here's an x squared minus 4. That's a quadratic. I might be able to factor that. And in fact, I can. The way that I do that is by noticing that it's a difference of squares. In other words, it's one thing squared minus another thing squared. And we remember from when we learned how to factor difference of squares that you have the square root of the first thing minus the square root of the second thing. That's one factor. And the square root of the first thing plus the square root of the second thing, that's the other factor. So, just because we finished grouping doesn't mean we could stop factoring. We still had to factor the difference of squares polynomial. That was one of the factors. So we end up with 3 factors here. So let's find the zeros that each of these factors gives us. So if I make 2x minus 3 equal to 0, that would make that parenthesis 0. It would be 0 times 2 other things. That would make y equal 0. So let's solve for x here. I've got adding 3 to both sides and dividing both sides by 2. X is equal to 3 halves. That's going to make this factor 0, which is going to make y equal 0. Let's solve the second equation. X minus 2, I'm going to make that equal to 0, add 2 to both sides, and I have that x is equal to 2. That's going to make this factor 0, which is also going to give us a y of 0. And then finally, x plus 2 is equal to 0, so let's subtract 2 from both sides, and I've got that x is equal to negative 2. So I get 3 zeros from all 3 factors, and the zeros are 3 halves, 2, and negative 2. There's my zeros for this polynomial. The important bit there, again, was to recognize that even when I finished grouping, I still had to factor the difference of squares so that I got 3 factors and 3 zeros. Do you always have to factor a difference of squares polynomial after you do grouping? No, not always. Sometimes it's not a difference of squares polynomial. Let's take a look at an example of a cubic four-term polynomial that doesn't leave a difference of squares polynomial that you have to factor. So, if I'm finding the zeros of this polynomial here, I'm going to make y equal to 0, and then I'm going to factor. So, let's do that. I'm going to take the GCFs out first. GCF of that is 4x squared. GCF of the second term, well, it's really just 1. I can't take anything more than 1 out. So if I take 4x squared out, I've got 5x plus 1. And here I've got, if I take 1 out, I still got 5x plus 1. And I have matching factors. That's good. So then I bring the matching factor out to the outside. And my other factor is 4x squared plus 1. Now, look at our answer here. Again, I have a linear factor that can't factor anymore. I also have a quadratic factor. Can that factor more? Well, if I look at it, it's actually a sum of squares polynomial. What we learned about sum of squares polynomials is that they are not factorable, which means that this form is as far as I can go. I can't factor anymore. I have to stop here. So let's try to find the zeros now. If this first parenthesis equaled 0, if 5x plus 1 equaled 0, then y would equal 0 because I'd have 0 times something else. What x would give me that this factor equaled 0? Well, if I subtract 1 from each side, and I divide each side by 5, I've got negative 1 over 5 is equal to x. So there's 1, 0. Now the question is, do sums of squares polynomials have zeros? In other words, can I make 4x squared plus 1 equal to 0? The answer is no. I can't do it. Last video we learned that sums of squares polynomials don't equal 0 for any real x. Okay? Now, to see why, you could subtract 1 from both sides. You don't actually have to do this, but if you subtracted 1 from both sides, and if you divided both sides by 4, and if you took the square root of both sides to try to solve for x, you'd have that x is equal to the square root of a negative number. And we know that that does not give you a real number. It gives you what's actually called an imaginary number, which means that there are no real roots for this sum of squares equation, as we learned last video. Now, you don't have to do all this work. You can just simply say that there's no 0 that comes from this factor. So if there's no 0 that comes from the sum of squares factor, then we only have the 1, 0. Our only 0 for this polynomial is negative 1 over 5.